Hello, in this video I'm going to derive the differential equation of a risk-free investment with continuous compounding. In the previous video, we have seen that S1 is equal to S0 times e to the power mu, where mu is the compound rate of the investment S0, the initial investment. Um, Also, I want to introduce a few other variables which will be useful for the future videos. The total return of the rate or a rate of return of the investment, which is R. Um, so the if this is going to be the return, if this is going to be the return of investment at the end of the first year, so we want to know what is the rate of return of that investment, because this is a compound interest. So for $100, what is the rate of return we want to find? So we have to use the R value to get that total rate of return of that investment. So to find that, S0 times 1 plus R is equal to the total value what we get. So here S0 we can cancel it out. So that means 1 plus R is equal to e to the power mu, and we are interested to find R, which means R is equal to, if this goes here other side, it becomes a negative. So that is R we can take this 1 and bring it here, which means uh, which means if I take this and bring it here, then this becomes -1. So R is equal to e to the power mu minus 1, which is what I made it here. At the same time, if you want to find the compound rate, if you want to find the compound rate in terms of R, then it means we can take this. It becomes 1 plus R equal to e to the power mu. So if you take log on both sides, then this becomes mu. This becomes mu, and then it is a log 1 plus R. That is the compound rate in terms of rate of return. So I touched on the previous video of the exponential growth. Let's say ST is the value of investment at time t. Then it means the return of the investment at time t is going to be S0, which is the initial investment, times e to the power mu, the compound rate, times the number of years. Since this is e to the power mu t, as t increases, um, as t increases, um, uh, the value of this term is going to increase exponentially, because this is exponential curve. So you can see that there may be a steady increase, and again at one point it is gonna go up exponentially. So that's why in the investment, people say that we got to invest as early as possible, so that we can have a significant rate of return, so which we will see in the future videos. um, then from this, I want to see how we can get the differential equation. So what I want to do is what I want to do is um, uh, from here, let's say we have a duration like uh, t plus tt, which is t plus tt, which is so t plus tt, again, that is small duration added to the time t. By just applying the previous formula, then the return of the investment S0 after this duration t plus tt is going to be S0 times e to the power t plus tt mu, and we gonna just split the exponential part term, and then it becomes s of t times e to the power mu tt. Again, this is going to be uh, s of t. Then we want to find the differential equation, which means like what is the change of investment between two period. So we found from this equation that what is the value of the investment after t plus tt. And if you want to know what is the change in the value of the investment from t plus tt to t, we basically have to subtract these two values. We have to So that's what exactly I did in this equation. um, if I subtract it, then I know you can see that s of t is a common term. S of t, so if I take s of t out, it means s of t times e to the power mu tt minus 1. So again, if I take s of t to the other side, it becomes ts of tt ts t divided by s of t equal to uh, e to the power mu dt minus 1. And again, this equation holds good for all t, so I'm generalizing it. Ds by s is equal to e to the power mu tt minus 1. So this is a general differential equation of the investment behavior for a risk-free investment for the compound interest.